Welcome all to the Max lecture series. So in the last session we understood how to apply Rolle's theorem for any functions, and I hope you also understood where it will be failed, where it will exist. Suppose if Rolle's theorem is existing, then how to identify a particular point between the given interval. Everything we understood. Now in this lecture we are going to learn one more mean value theorem, that is called Lagrange mean value theorem. Shall we start? Yes sir. See, in order to apply Lagrange mean value theorem, you have to understand the function first. Nothing is there. It is as usual Rolle's theorem. In Rolle's theorem, actually we will be testing or we will be checking 3 points. Whereas while applying Lagrange mean value theorem, you don't need to check 3 conditions. Only 2 conditions are required. One is check whether the given function is continuous in the closed interval, whereas the given interval is 2, 5. The second test is check whether the given function is differentiable in the open interval of the same given data. Anyway, given it is polynomial equation, it is always continuous and it is always differentiable too. Only these 2 conditions are required while applying Lagrange mean value theorem. Whereas while applying Rolle's theorem, you have to do 3 tests. Test number 1, you have to check whether it is continuous or not in the closed interval. Test number 2, you have to check whether it is differentiable or not in the open interval. Test number 3, you have to take the given interval values, identify its correspondent values and check whether they are equal or not. If they are unequal, then mean value theorem is failed to apply. That is, Rolle's mean value theorem is failed to apply. So here we are focusing on Lagrange mean value theorem. While applying Lagrange mean value theorem, only 2 conditions are required, as I told you that. Okay sir, once these 2 conditions are approved, then what can we do? Third step, take the function f of x. What I told you, the given function f of x equal to x square plus 3x plus 2. Yes or no? Yes sir. Now what you have to do is, once again differentiate the function once, f dash of x, then it will become 2x plus 3. You all know. After identifying this, what you have to do is replace x by c. As usual, same thing what we did in Rolle's theorem. After satisfying 3 conditions, we have to identify the existing point between the given interval. So here also in Lagrange mean value theorem, in order to identify the existing point between the given interval, we are going to use one more procedure. What is that the procedure? The procedure is find the first order derivative, then replace x by c, that unknown point. We are going to find out the unknown point. So f dash of c can be written as 2 times of c plus 3. After that, find out take the intervals. What is the given interval? 2, 5. Find the value of f of 2. Of course, you also have to find out the value of f of 5. What is the value of f of 2? F of 2 means I have to replace x in place of x. If I will replace 2, then it will become 2 square plus 3 into 2 plus 2. This will be equal to 3 times of 2 will give you 6. 6 plus 2 will give you 8. 2 square will give you 4. 4 plus 8, overall it will be equal to 12. When we are replacing x by 5, 5 square will give you 25. 25 plus 3 times of 5 will give you 15. Plus we are also having one more 2. See there, 15 plus 25 will be 40. So overall value will be equal to 42. Okay sir, after identifying these 2 values, what I have to do? The thing is, take the value of f dash of c, just equate it with let me write like this, f of b minus f of a upon b minus a. Sir, here which one is f of b, which one is f of a? See there, first point is always a, second point is always b. So you have to subtract b minus a and you have to subtract f of b value minus f of a value. That's all. So if you do like that, then you will be getting the point c. Shall we proceed now? F dash of c can be replaced by 2 times of c plus 3 will be equal to f of b. B means 5. Its correspondent value is 42 minus f of a means, in place of a, here we have 2. So that can be replaced by 12 upon b minus a. B is 5 minus a is 2. That will be equal to 3. Now if you proceed further, this will give you 2c plus 3 equal to 42 minus 12, that will give you 30 upon 5 minus 2 will give you 3. 30 by 3 will give you 10. So from this I can say 2c plus 3 equal to 10. If you pass the 3 to the right hand side, then 2c will become 10 minus 3 is 7. So c is equal to 7 by 2 will give you 3.5. Now check whether this point is existing in the given interval or not. Yes sir, given interval is 2 comma 5. Of course 3.5 will be existing between the points between 2 comma 5. That's all. So that is how we are applying Lagrange mean value theorem. So let me repeat quickly what we have to do. Check the given function is continuous or not and differentiable or not. In the continuity will be, you have to check the continuity in the closed interval, check the differentiability between the open interval, then take the given function, differentiate it once, and then take the interval values 2 comma 5, find the value of f of 2, f of 5, and then just we have to find the difference between last value f of 5 minus f of 2, in the denominator last value minus, that is upper limit minus lower limit, b minus a. Substitute all the values in this format. See that I have written the generalized format here, and then just to reduce the expression you will be getting the answer. That's all. I hope you all understood how to calculate the point C, or how to check whether the Lagrange mean value theorem will be existing or not. Remember one thing, if your given function is failed to satisfy any one of this condition, then you can't apply Lagrange mean value theorem. Okay, so this is all for this lecture. Remaining things we will see in the next class. Thank you all.